Okay, in this example, we're going to go ahead and take a look at some problems that are not in a traditional factored form and a application of the factored form. Now, if we look over here, this, believe it or not, is in factored form. Okay, and what we want to do is we need to think about these pieces a little bit differently. First of all, is that I want to make sure that you guys know is that A does not equal X. Okay, A is always a numeric value. And so therefore, I'm going to put a number in front of that X right there. And that is going to be our equivalent of A. We also are going to go ahead and say, like, sometimes X is all by itself. We know that this has a minus P and whatnot, but sometimes this could be like a 0 here. So the X, when we bring it down, we're going to go ahead and set it equal to 0, okay? And it's going to solve itself. So let's just be on board for a minute and see where this takes us. So first of all, we need to find out what A is, and A is 1. So we write A equals 1, and so therefore, and that's our first step over here, that A is going to be positive, so it is going to be opening up, okay? Now, here is the second part, is that we want to set, and I know that this says, go ahead and set each part equal to 0. So here we go. A little bit difficult to see, but follow me. Is that X is like this part right here. Even though there's no P, there's no value that's being subtracted. And so we're just going to roll with that for right now, and I'll show you how to set it up. And this is equivalent to that. So therefore, here we go. To find the x-intercepts, we're going to go ahead and we set x equal to 0. And we get the x right here, okay? Notice that there's nothing attached to that x, and that's okay. So x equals 0 is probably, that's already solved for us, which is good news. And so therefore, we just need to do the x minus 4 equals 0. And so to line things up and kind of color coordinate them, we're going to get, that part, and this defines that part. And just to follow up, that's that guy right there. So when I'm going to solve for x, notice that I don't have to solve for x because it's already solved. X equals 0. And for the next part over here, or I should say, part that's highlighted in green, when we add 4 to each side and bring it down, we just got a little bit of algebra to do, and so x equals 4. So that means is that we have the following as our x-intercepts, okay? So writing this out, our x-intercepts are the following. We got from the red part 0, 0, and from the green part we got 4, 0. And let me highlight those so we can just see how all these pieces are lining up. Okay, so let's plot these points, and I'm going to go, oops, wrong marker. So we go over here, this is 0, 0, and this is going to be 4, 0. So now we are on step 3, when we find the vertex, and there's a little bit of work to do with that. So we know that we have to add the x-intercepts, okay? So we're adding 0 plus 4, so writing that out. So we go 0 plus 4, just 4, and then we got to divide that by 2, and so that ends up being 2 is our x value of our vertex. So what we do then is that we plug that 2 into the original, which is over here. And so every x is going to turn into 2. So I get the following. 2 parentheses, and then we got 2 minus 4. So we know that 2, and then 2 minus 4 is a negative 2, and we get at the end of the day, a negative 4. And that's the y value of my vertex. So I know that my vertex is 2, comma, negative 4. So 2, negative 4, and it looks like I'm going to plot my point right here. All right. Draw the line of symmetry. Just like that. And so we know that the line of symmetry is always going to be this business of x equals the x coordinate of the vertex. So I'm going to move a little bit off the page. I know I have to write large because I'm dictating a video. And so for the fourth step, we're going to get x equals 2. Now, finally, we need another point that is going to be strategic. We're looking for any x values that don't have a point on them. So that leaves 1. It doesn't have a value on there, or 3. I'm going to plug in 1. It's easier to work with. So step 5, for the strategic value, I'm going to plug in 1. So therefore, that means is that I'm going 1, and then plugging this in, 1 minus 4. And at the end of the day, when I plug 1 in there, that is going to give me 1 times a negative 3, and that will give me negative 3. So my strategic value is going to be 1, comma, negative 3. And I plot it like this, and reflect it over here. And now I have my parabola. Kind of doing a smooth curve through there like that. Okay. And so there we go. That's how we would do something that is in a kind of a non-traditional or a non-standard factored form right here. Okay. Where some of the x's are left off. All right. So that said, let's go ahead and take a look at the application that is going to be expected of us. Okay, so in this application, we are launching a bottle rocket. And the bottle rocket, and I'm paraphrasing here, is given by this function right here, okay, where f of x measures the height above the ground in meters, and x represents the horizontal distance in meters from the launching point. So what I want to do is that I'm going to create a graph, or I'm going to, just go ahead and sketch things right here. And we know that f of x is going to be the height. And we also know this business is that this is going to be the distance that it went, so the horizontal distance. And what we want to do is that we want to go ahead and run this particular function through the 5 steps and then answer the questions below. Okay, so let's just concentrate on this function right here, and I'm going to write it up here such that we can apply the 5 steps to it and see where that takes us. Okay, so I'm going to write the general form right below it, which is going to look like that. So we can see, if I put a negative 1 here, we can start to line up the A and the other parts that we need. Okay, so first things first, we look at, oops, wrong marker, is that we look right here and we know that step 1 from our other examples, okay, is that step 1, we're going to go ahead and have A is negative, and so therefore our parabola is facing down. Okay. The next part then is to equate the parts, the factor parts of that parabola to those guys and set them equal to 0. So that means I'm going to find the next part. I keep doing that. Right here, I get x minus 1 equals 0, and I get x minus 6 equals 0. I solve them out, adding 1 to each side, adding 6 to each side over here, and so therefore I get my x-intercepts. I get x equals 1 and x equals a 6. Okay, so let's start the game plan about this this problem. Is that if those are x-intercepts, I know that I'm going to have to label the x-axis. And so I'm just putting some points here. And we're going to do this as 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay? And so we know that the bottle rocket is going to go ahead and we're at 1, and we are at 6 right here for our x-intercepts. Okay? And so from here, we can kind of visualize that, and we know that's going down, that the bottle rocket was launched here and probably is going to go something like this. Okay? But we need more information. We can't just go ahead and guess. So going on to step 3, which is find the vertex. And so our vertex is going to look something like this. We're going to add the two x-intercepts, which is going to be 1 and 6. We know that's 7. And then we divide that by 2, and the x value of the vertex is going to be 3.5. So that's our x value. Now we need to plug 3.5 into the original equation and see what happens. So let's go ahead and do that. So I go negative, sorry about that, a negative, and then we have plugging in 3.5 minus 1 times 3.5 minus 6. Okay, so we can plug that into our calculators and we find out that it's going to be, all right, so that's going to give us from our calculator, and it's going to give us 6.25 or 6 1/4, and that is our y value. All right, so we know that our vertex then is going to be, our vertex is 3.5 comma 6.25, which is going to have to map out 1, 2, 3, 4, 5, 6, 7, and so we can kind of map this out as 3.5 is right here, and then going up around to 6.25, and so we are looking at around here, I suppose, and our vertex is 3.5 comma 6.25. Okay, so for this last part is that we know we need to go ahead and draw the line of symmetry. So the line of symmetry is going to go ahead and do this. And here is one of the tricky parts of this example, okay, is that usually the last part is to go ahead and find the y-intercept, okay? And I'm going to show you why the y-intercept is not going to be useful in this situation. So if I were to plug 0 in to the original equation, we would go ahead and have something that looks like this, okay? And so that's going to give me a negative, and then I would have 1 times 6, so that would give me a negative 6. Now notice that the height, okay, this height right here, it would be a negative 6, and just extending this line down, and it would be a negative 6 somewhere in there. That's not useful because it doesn't make sense. What we want to do is that we want to revert to that strategic point stuff and look at values like 2 and 5 and 3 and 4 that do not have a value on them or a point on them such that it will complete the parabola. So let's go ahead and I'm going to plug in 2 because it's one of the easiest, and I'm going to go to a strategic point. And the strategic point, I'm going to go ahead and, like I said, pick 2 and plug it in. So I get 2 minus 1 times 2 minus 6. And let's see where that takes us. And again, that's our input here. So let's knock it down. I got this guy right here. And it's a negative sign. I put a -1 there. Times 1. And then this is going to give me a -4. So at the end of the day, that's going to give me 4. So I know that I have a strategic point at 1, 2, 3, 4 right here. And then I reflect it. 1 and a half, and 1. And so I know that my last point is right here. And now I go ahead and I have my graph. And now I can start answering some of these questions. So let's set this up to answer some of these questions, highlight them out, and then answer them in a rewarding way from our graph. Okay, so first question that we want to tackle. It says, how far does the bottle rocket travel in the horizontal direction from launch to landing? So we can see it's launched right here and it lands right here. So pretty straightforward, even counting spaces, we can see that it has gone 5 meters. Okay, so therefore, I'm going to go ahead, I will call this 1, and so the first answer is that it has gone 5 meters. Okay, number 2, let's take a look at the second one. Okay, it says, what is the maximum height the bottle rocket reaches? So we can determine that by the y value of the vertex, which is right here. Okay, so our second part, which is, a little bit of technical difficulty, number 2, is that the highest point, it's going to be 6.25 meters. Okay, and so let's take a look at the very last part. It says, how far has the bottle rocket traveled horizontally when it reaches its maximum height? So, how far has it reached? Okay, well, we know that it's gone vertically 6.25, but it's traveled 3.5, which is going to be the x value of the vertex. So at 3.5 meters, the bottle rocket is at its highest point 6.25 meters. And so therefore, looking at our very last part, number 3, is that after 3.5 meters, it's going to be at its highest point. Okay, so one of the things that we want to keep in mind is that we want to always go ahead and trust our graph. All of these questions are much easier once we have our visual on our graph. We also want to go ahead and be very aware of the fact that some of this stuff, like the Y-intercept right here, would be nonsense. And we have to revert back to some strategic points to fill out our parabola such that we can answer these questions in a rewarding way. So that's how you do that. Good luck in your adventures with the problems, and I will see you in the next lesson.